Hi, I'm Wendy Zuckerman, and you're listening to Science Versus. So recently, scientists discovered this super weird thing early in the universe. It's so strange that it's making some nerds question our theory of everything. Like, everything. This story, it's so bonkers and not really that well known that I just had to share it with you. It comes from our friends at the podcast Unexplainable from Vox Media. And Unexplainable explores scientific mysteries and unanswered questions, and it doesn't get much bigger than the story we're sharing with you today. Brian Resnick is reporting, and Brian's interviewing Professor Caitlin Casey, who studies how galaxies form at the University of Texas. I really hope you enjoy this episode. What the hell is at the edge of space is coming up right after the break.
Standing by for terminal count.
2 years ago, on Christmas, I was pretty pumped up. And not just because it was a day off work. Humans were launching this giant new gizmo into space.
And liftoff.
This is the future. NASA's James Webb Space Telescope.
The James Webb Space Telescope, which is a mouthful, so sometimes it's just called JWST. This thing is the latest, greatest space telescope, better in many ways than its predecessor, the Hubble.
It can peer deeper into the cosmos than any previous orbiting observatory.
It could just do so much stuff, like investigate planets orbiting other suns.
Take a look at this, a giant red planet outside of our solar system.
It could observe the birth and demise of stars.
What we're seeing here is essentially a stellar nursery.
But the thing that I think is coolest about it is that
we're going right up to the edge of the observable universe.
That's astronomer Caitlin Casey. She actually gets to use the Webb telescope. And I talked to her before it launched. We chatted about how things very far away in space in a telescope are actually also very old because the light has taken a long time to reach us. And with the James Webb Space Telescope, some of that light is almost as old as the universe itself.
We're trying to see which galaxies turned on first.
This was a couple years ago, and I just wanted to get an update from Caitlin. Has JWST, has it lived up to the hype? And to put it simply, Caitlin and her colleagues, they are just starstruck.
I use every second that I can squirrel away from my family, from teaching my classes at the university. I use every second of every day to just look at these images and dig deeper.
Is JWST getting in the way of relationships, family, or is it destroying lives?
Yeah, well, it's funny. I have 3 kids under 3, so my life, mandatory. I have a lot of balance of personal life. But yeah, after the kids go to bed, that's when the data pops up and we're working again because it's just so fascinating.
I really wanted to know, what is she looking at on her laptop that's keeping her up at night?
Wild things in the early universe. At the earliest times, the universe was having a party, and we had no idea it was happening.
Caitlin says that before the Webb, she thought there just wouldn't be a ton to see so far back in time.
We thought we would maybe see a couple of more distant galaxies, but they would be very, very rare.
Instead, they're seeing something unexpected. And this is what's just amazing to me. This telescope turned on, and now we have one of the new biggest questions in science. It's sending researchers into a frenzy to try to explain what the hell is going on.
The party that is happening in the early universe is really shocking to astronomers.
So that is today's show. What has the James Webb Space Telescope discovered that is so shocking?
How far we have come. And still have to go. How far we have come.
Each one tells us
how far we have come.
what is the party? What is like the most surprising thing that Webb has shown us?
Yeah, so JWST has been mind-boggling because we have found really mature, large, bright galaxies back even further than we expected.
Mm-hmm.
There are extraordinarily massive, mature galaxies at this time that we had no clue.
Mm-hmm.
It's really baffling. And it's looking at a time in the universe's history where we're really starting to butt up against the age of the universe itself. It's how do you form Rome in a day? Like, you can't form Rome in a day, right? Because it's just, there's too much to do. And these galaxies are Rome, and they have formed in a day. They are unusual in almost every way, and they've had very, very little time to assemble.
Wow.
Another helpful analogy that I really like, if you think about generations of people and their families and how that progresses, it's as if your grandparents were only like 4 to 5 years older than you, and your parents are only a year or two older than you.
So this is as weird as learning your grandfather grew to be an adult in 4 days and then started his own family or 4 years, or whatever it was.
Yeah, that makes no sense, right? So that's what's happening to stars in these distant galaxies.
What do they look like in the images you see?
They look like faint smudges. They are just unassuming dots of light. That looked like almost every other unassuming, dot of light.
You can infer from these smudgy little blips of light that they are actually huge and mature and very bright and bigger than you'd expect for the time period.
Yeah. So instead of just taking a single picture of a galaxy, we're able to understand how much energy comes out in all sorts of different types of light. We say a picture is worth 1,000 words. That's absolutely true. But, a spectrum is worth 1,000 pictures. So it's just so much information. It's like a fingerprint for all of these different galaxies. And these dots are little smudges on the sky, barely visible. And, if you just have that image, you can guess that it's a distant galaxy, but you don't know much about it. You don't know how massive it is. You don't know what it's made out of.
Yeah.
But these are things that we can tell by reading the fingerprint, the chemical signature of these galaxies from their spectra. And so that's been astounding.
Okay, so there are early big galaxies in the universe. So what?
Yeah, so what is right? I mean, it's a good question. And it turns out that if you really dig into the details of that question, it's a challenge for not just astronomers, but physicists to come up with a way where you can form something so big so quickly in the short period of time after the Big Bang.
So are you basically telling me these early galaxies, we have no idea how they formed?
Well, I think we have an idea of how most galaxies form. Later on in the universe's history, they build stars from gas, like hydrogen gas that's in space, right? And over time, they're building more and more stars, and those build up. But when you push it to the limit and find a lot of stars very early on in the universe's history, then you have to come up with some other explanation. And some folks want to throw out our cosmological model completely. And that is, that would change everything we think we understand about the universe.
Wow.
But, not everyone is digging that.
Yeah, wow. I do want to get to what are the possibilities here. But before, I feel like it's good to ask, are we really confident that these galaxies are as old and as bright and as weird as you're saying?
Another great question. And boy, have there been debates about that at conferences. Tomatoes have been thrown, let me tell you.
Literal tomatoes or metaphoric ones?
Metaphorical, of course.
Oh,
yeah, we're
darn.
quite civilized.
Yeah. If what the Webb telescope has discovered aren't big, bright galaxies, what are they? That's after the break. So I've been talking to astronomer Caitlin Casey about whether these weirdly large, mature galaxies spotted by the Webb telescope are really what we think they are.
Yeah, it's a huge point of debate whether or not these are actually as massive as we think. But the alternate explanation, get this, is also really confusing.
Mm-hmm.
If they aren't as massive and bright and big as we think, then maybe we're looking at some of the most massive, supermassive black holes.
What?
The reason that is disturbing is because just like we don't know how to form stars really quickly, we have really no clue how to form black holes that are so massive.
So, you're saying that the telescope has picked up that these are really bright, they're really big. We're assuming they're galaxies, but also a black hole could be bright and big?
Yeah, so they are galaxies for sure. But there is a situation where the light might not be coming from stars. And the alternate option is that light is coming from a very, very hot disk of material that is being sucked into a giant black hole. And that disk of material is so hot that it shines really brightly. It can even, in some situations, outshine the galaxy in which it lives.
Wow. Before you said that, some people are saying, maybe we need to throw out our cosmological models. And I was curious one, what is the cosmological model? And two, why does this even implicate something that sounds so big like that?
Yeah, it actually means the theory of everything. It tells us the physics of the entire universe. It is the scaffolding on which we build our understanding, And if we have to take that scaffolding down and rebuild it, then we really have no clue, what reality is.
So when you say, some people are even thinking about rewriting the cosmological model, what's a small piece of that? Rethinking of how gravity works, or rethinking how, some of the, something like that?
We're not necessarily, I think, most astronomers are pretty cool with gravity. we're not going to throw gravity out anytime soon. But for example, something we don't understand, dark energy, maybe we don't understand it at another level. And it could have been doing something different than what we think at really early times. So, for example, if you inject a little more energy into dark energy in the short period of time after the Big Bang, then you could maybe get out what we're seeing with JWST.
Have you heard any compelling stories of how these stars form so quickly? How these, what are some good guesses here?
One explanation, which is kind of cool, is if you think about the early universe, it's a really dark place compared to where we live now. There are all sorts of galaxies with lots of starlight flooding out into space and filling the cosmos. And that light actually impacts how stars form out of new gas clouds. It makes it harder sometimes to form stars. And so in the early universe, those floodlights are not on. And so you could form stars really, really quickly in a way that can't happen today because right now the floodlights are on.
That's interesting. The idea is that starlight itself impedes the development of other stars.
Yeah, yeah.
And it sounds like these explanations you're just telling me maybe fit within our cosmological model and just, without throwing it out.
Yeah, exactly. And, as scientists, that's what we aim to do first because, our cosmological model does a pretty good job. Yeah. It explains a lot about the universe. And anytime you change it, everything is affected. Yeah. And so you kind of don't want to throw out the prevailing theory until you absolutely know that it's wrong. And so, we try to come up with explanations within that scaffolding.
What's next? How do we figure out this mystery? What happens?
We are digging deep into these data. I mean, I can tell you again, we have just scratched the surface. There is so much more to learn. We're still digging through these remarkably large deep field images that we have. We want to take spectra, again, to get the chemical signatures of these galaxies. Those spectra also tell us that there are supermassive black holes in these galaxies. We want to precisely measure how common they are at different times after the Big Bang. And in the assembly of all of this research, I think we'll start to emerge with a new picture of the infant universe, this first couple 100 million years, in hopefully, the next year or two. Don't quote me on that.
Do you ever wonder, I feel like embarrassed asking this question almost. I don't know. Do you ever wonder if the universe is just here to mess with us?
I do. I mean, you look back on history and man, some very, very smart people have been totally flabbergasted at what the universe has revealed. Did Einstein like the expanding universe? No way. He was not a fan. Yeah. That makes no sense. Does the acceleration of the universe make sense? No. Yeah. So totally. In some ways, I'm just man, how cool that the story of everything is just so profoundly different than what we would expect.
Overall, just why is it important to understand this early universe and this, this hiccup in our understanding?
I will always go back to the explanation that, when we look out on the cosmos, it is us looking out on what we are. Yeah. I mean, this is the ultimate origin story, is where we came from. And if we can get a better understanding of that, then I think it's really beautiful. The crazy, wild universe that we live in, that we can come to understand it from within, is a pretty profound thing to me.
Is it kind of like us humans have been kind of put inside this puzzle box? And even if there's no prize in solving the puzzle box, who knows what the prize is for solving the puzzle box? But it's just I
mean, I think that's the ultimate prize, isn't it? Is if you solve the puzzle box that you live in, you've solved it. You figured it out. I mean, there could be no better accomplishment. Yeah. And it's just a real privilege that astronomers get to do this for a living, right? That we get to try to solve the biggest puzzle there is. Yeah. And I just love it.
And the puzzle is?
The puzzle is, what is this universe and why is it so bonkers?
That was an episode of Unexplainable from Vox Media. Full credits are in the show notes. You can find more episodes from them about all kinds of stuff, like what's up with those orcas attacking boats? Why do we cry? And there's even a deep dive into why some athletes choke and get something called the yips. Science Versus will be back next week, and I cannot wait for you to hear this episode. I'm Wendy Zuckerman. I'll fact you next time.